Well, welcome to Thursday Night Pre-Calculus. My name is Curtis Brown. I am joined by Vicky Carter, Tom Dick, and Steve Kokoska. Super excited to have them on here tonight. We're going to be talking about a perfect fit and looking for exact models versus when do we do regression and approximate models and how do these things work together on the AP exam. So looking forward to learning a little bit from each of these guys as we go through this session tonight. So Steve, I think you're taking it away.
Thank you very much, Curtis. Wonderful to be with all of you again. Curtis, I hope you're at the top of your game tonight.
Top of my game tonight. I'm
We've got
ready to
some,
go, Steve.
all right, we've got some good questions for you.
And if I don't know, I'm going to pass on to Vicky.
Okay, all right,
I might even do that if I do know, because
Well, we're going to start out with a couple of modeling questions. There's an awful lot of technology in here. You guys know, Tom and Vicky especially know that I really enjoy using the TI-Nspire. So I'm going to show a couple of technology screens here along the way with the Inspire. Tom and Vicky will probably do some interesting things with the TI-83, 84. And if we have a little time towards the end, we're going to try to take a look at the free response question number 2 from last year's or this year's 2024 exam. So let's see what we can do with this one. There's an awful lot of words on this page. Curtis, bear with me as I get through this one. It was a hot summer in Bloomsburg, and the local Ace hardware store was selling fans. They were jumping off the shelves. And so these portable fans were sold by this store during this heat wave. On the initial day of the heat wave, which we'll call time t equals 0, they sold 14 fans. 4 days later, they sold 26, and 8 days after that, on t equals 12, they sold another 26. So we're told in this problem that the number of fans can be modeled by this expression. We're not going to look for anything approximate. We're told that that's the model that fits. So F of t is the number of fans sold on day t. So the very first thing we want to do is to use the information in the table, use the information that we're given about this model, and we want to write 3 equations that can be used to find the values for these constants, A, B, and C, in that model. And then we're going to do some estimating here with the average rate of change and a secant line, and we're going to compare that estimate to the model, and we'll get there. So let's work on A first. Let's see if we can write these 3 equations and see if we can solve them. So here are my 3 equations, and let's see, how the heck did I get them? Well, I used the information given to me in the table, and I'm going to scribble just a little bit here. This first equation comes from f of 0, we know is equal to, what was it, 14, I think. And I just plugged in t equals 0 into the model equation. So that's a times 0 squared plus b times 0 plus c. And of course, those 2 parts of this are gone, and I'm left with just c is equal to 14. For the next 2 equations, well, I use the additional information in the table. That is that f of 4 is 26 and f of 8 is 26. I took 4 and plugged it in for t in the equation, and I took 8 and plugged it in to the model equation.
Steve, I think it's
12.
12.
Oh, it's 12. I
Yep.
beg your pardon, right here. Yep. I beg your pardon. That's a 12. Okay, so how do I solve that system of equations for A, B, and C? Well, the first one, C, is pretty easy to solve, but let me back up just a little bit. What would happen? This is probably a question for Curtis. What would happen if we had a more complicated expression in here in A, B, and C? Do you know a system, or do you know a way here that we would go about solving this system of 3 equations and 3 unknowns? Curtis, can you give me sort of an idea about how you might do that?
Steve, man, you're putting me on the spot right
Oh,
here. I'm gonna let
no.
Vicky do this one while I think about it.
Well, Vic, help me. What would you do there?
Well, I mean, we can do it algebraically, which you've kind of shown us, But technology, this is a calculator active question, so
Hmm.
teachers and students should be fairly well versed in how they could handle the technology to solve these.
Fantastic. And we'll see some of that, I think, in a minute. And Curtis, what I was also thinking about is if this is a system of three equations and three unknowns, and they're all linear equations here in A, B, and C.
Yeah,
And so what I might be able to do is to work to eliminate a variable here.
that's what I was thinking you might be able to do is do a little bit of work. I mean, C is conveniently equal to 14. You
Correct.
already gave me that. But supposing that we had a little bit more work to do, we could get that first expression in terms of C and then kind of work to eliminate that, substituting, setting myself up with the system of two equations and then doing
Two
the
unknowns.
same thing.
Very good.
Right. I mean, you could
Very
do
good
the work algebraically if you needed to, but I think like Vicky said, I mean, this is a great time
to
where your
use
technology
technology,
can be
isn't it?
very helpful.
All right. So good. Very good. So I know that C is equal to 14, so I took C equal to 14 and plugged it into these two equations and did a little bit of simplifying. Now I have two equations and two unknowns. And now here's my algebraic technique. What I did is I multiplied the top equation by a -3. And I did that because I could see that if then I added the two equations, the terms with the B would cancel out. So I multiplied the top and the bottom, pardon me, the top equation by a -3. That results in this system equations. Now I'm going to add the two equations, and the -12b and the +12b will cancel. If I've done everything correctly here, I'm left with 96a is equal to -24. I divide both sides by that 96, and a is equal to a -1/4. Pretty cool. How do I find B? Well, I go back to any one of these equations here. Any one of these two equations I think would be the easiest. And I guess I use this top one. And I plugged in that -1/4 for A, and I solved for B, and I've got a B equal to 4. So after all of that, answering this AP style question, I wrote the system of equations, and then often Vicky helped me here. Don't let me make a mistake. The next part of this is, well, go ahead and solve the equations. And I did that, and I've come up with this model or these coefficients on this model here. And there it is. F of t is -1/4 t squared plus 4t plus 14. Pretty cool. Long way to go, but I think we've got that analytically. Let me take a quick look at this using some technology. Tom will probably show you some other. I'm going to show you a little bit with the TI-Nspire. What I first did here was I input this model expression for F. Now, I did that because I'm going to use it in my screen on the right-hand side. But actually, it is this expression that I really want to focus on because the TI-Nspire has a built-in command called solve, and it will automatically solve this system of three equations and three unknowns. Now, you can't see all of them on the screen here, but I do have those three equations written in here. And at the very end, I've told the calculator, well, look, I'd like you to solve this system for A, B, and C. And in fact, with just a press of the button, hitting enter, there are those coefficients. There are those constants A, B, and C. And boy, that is really cool. If you think about what we went through just a minute ago analytically, and the calculator does that so quickly and accurately for us, that's pretty neat.
So this is where teachers and students need to make sure they know how to use the tools that their particular calculator has in order to solve something like this. And yeah, I think Tom's going to show us something kind of cool in just a few minutes, but the tools are there. The
Yeah.
students and teachers just need to know how to use them.
And Tom knows this. I like to check my work with the calculator too. So confirm my results. And so what I did on the right-hand screen over here is I actually plotted a graph of that. Well, it's a parabola, and we know that it's a parabola that opens down because the coefficient on x squared is negative. But I just wanted to see, does it seem reasonable that those 3 points are actually on that parabola? And indeed they are. And so I feel pretty comfortable about this solution. So on the left-hand side, it was actually to solve for those constants. On the right-hand side, I just did a little bit of my own confirmation to make sure that I got the right answer. All right, let's take a look at part B. Part B says to use the data in the table to find, what was it here? The average rate of change and the number of fans sold in fans per day from T equals 0 to T equal 12. I kind of left out a little step in here. Not necessary that a student would have to write this on their exam, but I probably should have put that in here. The average rate of change we're finding here is f of 12 minus f of 0 divided by 12 minus 0. And I go to the table to find f of 12 and f of 0. And I did a little bit of subtraction and simplification. And son of a gun, this just works out to be plain old 1. How about that? So the average rate of change over that time interval, 0 to 12, is 1 fan per day. How about that? So what's an equation of the secant line, or the line that goes through those 2 points, 0, 14, and 12, 26? Well, y is equal to, there's the slope of t minus t sub 0, which is 0, plus y sub 0, which is 14. And that just simplifies really nicely to t plus 14. So the secant line is y is equal to t plus 14. And I use t rather than x here because, well, we were talking about time as the independent variable here. So then we were asked to use that secant line, use that line to estimate the number of fans sold at t equal 10 days after the heat wave started. Well, I do that just by plugging in up here. So this is t equals 10 plus 14, so my estimate is 24. Vicky, help me a little bit on this. I put an approximation symbol in there because we are really approximating how many fans are sold on day 10. You know that on the AP Calculus exam, we're not too picky about approximations and equals until we get the series. What's your assessment of how particular the readers were in the first year about these symbols?
I think they're fine not to have it. I mean, I would think a lot of students probably just wrote y equals
Yeah,
using their secant line equation. And while we're talking about the secant line equation, they could have, I wouldn't advise it. They could have written the other secant. I mean, they could have used the initial point as the 1226 instead of using the 014. The
yeah.
014, we just kind of, having worked with math a lot, knew that was the easier one to write.
Yes, yes. And so if we did that, what would we have here? Y
We'd
is
have
equal
y
to
equals 1 times
t minus
the t minus,
12,
yeah, yeah, plus 26.
so t minus 12
12,
plus 26.
yeah.
And
So
that
if you
better come out to be the same answer, and it
exactly,
does.
yeah, and it does.
Okay, very good. Good point. Okay, so we were asked to kind of compare this to what the model tells us is happening at time t equal 10. So I took t equal 10 and plugged that into our expression with the constants a, b, and c and got a 29. And now we want to compare this to the estimate found in up above, that 24, and explain why the two differ. Well, okay. First of all, we have this kind of exact model here, and we're getting an estimate with this secant line. And we know that this graph of f is a parabola that opens down, it's concave down. And therefore, this secant line is below the graph of f, and you can almost see it up here. I'm going to draw it again down below, but you can almost see this secant line here going through those two values. Oh, and around there is t equal 10. And so because the graph is concave down, the secant line is below the graph, and therefore our estimate must be below the value given to us by the model. And I think down below, with a little bit of luck, I drew that on a TI-Nspire. I just added a little bit to my graph up above. I added that secant line. You can see that it is below the model, the graph of the model, from t equals 0 to t equals 12. And therefore, our estimate at t equals 10 is less than what the model provides.
So,
That's pretty
Steve,
cool. I'm
yes, it
sorry,
is.
Vic. Go
But
ahead.
no, I think it's actually is good that you had these images of the graph of the model and the secant line. And I think it actually would help students to possibly kind of sketch it. And it may not look real good, but just kind of sketch it and then They have to talk about it though. That sketch can't stand alone. They're going to have to say something about it. But I think to have something to go by can make it easier when you have to answer the particular questions that are there.
Yeah, I'd like to say, Vic, that the four of us were really into this idea of visualization, and it does
Yeah.
help, doesn't it? It really
Yes.
does. Yep. Tom, a little bit of technology.
Sure, Steve. I'll give it a
Okay,
shot.
let's see if that works. There we go. Okay, all yours.
All right. Well, let me pull up my TI-84. I think I've got it up where people can see it. And this was one of these perfect fit questions, right? We were given a model and say, hey, this is the model that fits this data. What is it? Find these coefficients. But I was kind of curious what would have happened if we tried to do regression with this small set of data. So and this is also an opportunity to just kind of show how one does a regression on the 84. So what I'm going to do is actually go to the Stat menu and do an edit. And this is my we call a list editor, where we can enter lists of data. The lists are organized in columns. What I'm going to do in L1 is just put our 3 time values that were given to us. So those were 0, 4, and 12.
Mm-hmm.
And then I'll move over to list number 2, and here I'll put the corresponding number of fans that were sold on each day. And those were 14, and then 26 on both day 4 and day 12. Okay, so there's our data, and we could graph that data, but what I'm going to do is I'm going to go ahead and calculate a regression, a quadratic regression on those 3 data points. So I'll do a not calculate, but actually go back to the Stat menu and hit calculate in that environment. And if we look down our calculation choices, we see a bunch of regressions toward the bottom. And number 5, there we go, quadratic regression. So I'm going to go down to number 5. And, well, it kind of defaults to list 1, list 2. That's pretty convenient because those are exactly where we have our data. And I want to store the regression equation. So this is an opportunity to store that in my y equals menu. So I'm going to pull up.
Tom, let me just say, highly recommend students do that. The ones that are using the TI-84 to store it, because then you've got something to look at.
Yep.
Exactly. Yeah. And then you've got access to it to be able to do other calculations. So I'll pull up, we go to the bars menu, or if you do alpha trace, getting the shortcut to the y equals, not y equals, but to our y variables. And I'm just going to store it in y1. And now we'll just ask it to calculate. And boom, there's our quadratic. Wow, you even used the same letters as Steve did. Except our variable here is x instead of t. We just have to remember we're using x for time. And I believe those are exactly the coefficients that Steve came up with. The negative 0.25, well, that's negative 1/4, and then b was 4 and c was 14. If we wanted to graph this, might go to a zoom. And since we were dealing with data, I'll go ahead and do a zoom stat. So it'll kind of give us a window where the data fits. And let's see, you know what? I'm not sure I turned on my stat plot. So
I don't think we did.
Yeah.
So that was my mistake. Let me go to stat plots. There's plot 1. Yep, it's off. So let's turn that on. Okay, list 1, list 2, that's what we want. Okay. And let's try that again. I'll do a zoom stat. There we see those data points. And sure enough, it's a perfect fit. Now, if you were to trace on this, on a stat plot, it's going to jump from point to point in your data.
Mm-hmm.
Okay. So it's going to go from 0, 14, jump all the way to 426. and then to 1226. If we were to hit an up arrow and get to our regression equation, that's our quadratic. Now, if you trace, it's going to be tracing by, increments. It's actually tracing along the curve. So these are not corresponding to data points. These would be other points on that parabola. So for example, if we wanted, what was the actual number of fans on day 10?
Right.
We could just type in 10 and we get our y equals 29.
And I think it's probably off the screen because it's up above.
Yes, it's up the vertex. The zoom stat is making sure my 3 data points are on screen, but it's not quite optimal for seeing the whole parabola.
Yeah.
So if we went to our window and maybe bumped up our y max to,
Seemed like you could maybe make zoom fit work also.
Say that again, Curtis. I'm sorry.
It seems like you could maybe make zoom fit work.
Yes, and then it would be looking at the parabola itself and making sure that fit on the screen. Okay. Before I turn, so Vicki, would you? I'm not suggesting. So here's a case where with only 3 data points and a perfect fit, the quadratic regression actually is a way of getting that quadratic fairly easily with technology. We'd want to caution people that with more data points or these other nonlinear regressions, one has to be a little bit careful about that, especially if the intent is to solve for those coefficients. Vicki, would you want to suggest what I could do with technology to solve for those coefficients in another way?
Well, I guess we've already we talked about it a few minutes ago. We could use that app.
Okay. Why don't you take me through it?
All right, so let's press apps.
Okay, I'll quit and do the apps.
And it's number 9.
Number 9. I'll go ahead and scroll
Polynomial
down there so people can
simultaneous
see
2.
it. Okay.
I called it the plasmid a while ago. All right, we want
All
number
right.
2, simultaneous equation solver.
Okay.
And we have 3 equations.
All right.
And 3 unknowns.
Okay.
And I think everything else just can stay the same. So
Okay.
you need to press the graph button, which is next.
Okay.
And
So
then
here's where we enter our coefficient.
So the only thing that's going to be difficult for students here is realizing that XYZ is their ABC.
Yeah. So we'll have to do that kind of mental
Yeah.
translation to the variable.
Just kind of being careful there. Now you really have put me on the spot. So 0, 0. And
14.
First one was 14, was it?
Right. Right.
Okay.
Well,
no, that's
the first
1.
1.
The coefficient of C is 1.
Yeah. Excuse me. I was. Okay.
Okay.
So, and then we go to the.
I think if you press
There
enter.
you go.
Oh, there you go. And then 14.
14 is the constant on that other side.
Yeah.
Right.
Yeah.
All right.
Okay.
And then the next one.
So then this one is going to be
16.
Good. Thanks, Steve.
Yeah, that's okay. I got it in front of me. 16 and then a 4.
Mm-hmm.
Okay.
And then a 1.
Mm-hmm.
And then the constant on the right-hand side is 26.
Am I in the right place there?
Yeah.
I think so.
Okay.
All right, last line is 144. The next one is 12. And then just 1 once again. And then a 26 again on the right-hand side.
Okay. And
Perfect.
then you're going to press the graph key, which is
which
solve.
corresponds to solve.
Mm-hmm.
Hey, how about that?
And again, our X, Y, and Z are really playing the roles of the A, B, and C.
Yeah.
That's
cool.
That's pretty slick, Vicki. Thank you for demonstrating that.
Yes,
You're
thanks so
welcome.
much for holding my hand through that. It's been a while since I've used
I like it a lot, and it does correspond, Steve, to that
Yes.
way that we solve them on the Inspire very much.
Yeah.
It's just
Yeah.
that the Inspire gives you that wonderful option of calling it ABC, whereas
Yes.
this is just going to always default to like an X, a Y, or XYZ.
Yes. I see. Very cool.
You can use any three variables you want as long as they're X, Y, and Z.
Exactly.
All right. Okay. I'll stop the share and turn it back to you, Steve. How's that?
All right. Thanks, Tom. All right, here we go. We've got one more modeling question for you. And this one, we're going to find an approximate model. And this one has to do with selling of paperback books. So it seems like there might be this relationship between the number of pages in a paperback book and the cost. I think at least when we were going to school, we always thought about, boy, the number of pages in those calculus books was certainly related to the cost, wasn't it?
Yes.
Well, it seems this way. It seems like there might be some relationship between the number of pages and the cost of the book, and just sort of reasonably here, the more the pages, the more to produce, and therefore the higher the cost. So I went out and got a random sample of paperback books, and I counted up the number of pages, and I found the cost of each, and there's my table. And so the first thing I'm going to do is construct a scatter plot, and I'm going to see if a linear model seems reasonable. I'm going to find the regression line, and I'm going to interpret the meaning. This is a nice one too, of what that regression coefficient on X really means. And we're going to estimate the cost of a paperback book, and we're going to look at a residual plot and answer a question about that. So bear with me through all of this. I'm going to try to use a lot of technology also, have to here. And if I'm correct on this, Vicki, Tom, it seems to me that there are a number of ways to do regression on the TI-Nspire. But it seems to me that the data and statistics page is very helpful. I really like the visualization there and the ease with which that allows you to find some of these values. So here's what I did. I started out by putting these values in a lists and spreadsheet page, which is kind of like a mini little Excel spreadsheet. So I named column A pages and column B cost. And then what I did is I used the data and statistics page to get a scatter plot. And there it is on the right-hand side. So does a linear relationship seem reasonable? Well, yeah, these points kind of fall along close to a straight line. I can kind of see a straight line going up like that. I don't know, someone might look at this and say, well, it almost looks like there's a cubic polynomial in there, but that's pretty complicated and doesn't seem too reasonable as we think about this in the real world, practical sense. So I'm going to say in general, as the number of pages increases, the cost of the book also increases. Okay. So using the data and statistics page, it is relatively easy to find an equation of the regression line. And there it is. It's y is equal to minus 0.614 plus 0.012x. That's pretty cool. I've added a graph of that line to my scatter plot. And yeah, those dots, those points do fall relatively close to that line. I feel pretty good about this regression equation. What's the coefficient on X? It's 0.012. It's the slope of that line, but what does it mean in context? It suggests for each additional single page in the book, the cost increases by $0.012, a little over a cent. How about that? I like that. I think there's more of this move towards interpretation, looking at problems in context and being able to interpret some of the answers that we get. Let's take a look at the next part of this. What does the model suggest if we have a 725-page book? Well, there are many different ways to do this I found on the TI-Nspire, and this is probably a long-winded way to do it, but this is a way. When the Nspire actually finds that regression equation, it stores those coefficients in certain variables. One of them here is called stat.a, and another one is stat.b for the coefficient on X. And so I use those two variables my equation of the regression line to find that a book with 725 pages ought to cost about $8.35, according to my model. So long-winded way to do it, but a way to do it.
So Steve, probably when they set up their regression, and again, Tom, this is something I mentioned when you were showing the regression earlier. There's a place to store. The good thing about the Nspire is that it kind of gives you a default, like F1 or F2, whichever one is empty that's available. And for students, it's actually quite easy on that calculator screen to simply type F1, open parenthesis, can't remember what number you had, 700 and something or whatever.
725, yeah,
Okay,
right.
725.
Right.
And it will evaluate that function for them right away, which is really nice. But I really like the fact that you're showing them some other things about the calculator they may not know, that those values were stored as that stat.a and stat.b.
Yeah, these built-in functions that are available that we don't often use, but they're available. Yeah,
They're there, yeah.
they're there. So another thing we might look at in statistics is we might look at this residual plot. The residual plot gives us some indication as to whether or not the model is appropriate. What we're looking for in a residual plot is really randomness. We're looking at sort of a shotgun effect. We hope that's what we see. If we see some sort of a pattern in this residual plot, well, that's a suggestion that, well, maybe a different model is more appropriate. So here's my residual plot with this very limited data. And yeah, I think it does sort of look like a shotgun approach here. And so I'm pretty happy about this model. It seems reasonable. So the residual, remember, a residual is the difference between the actual value and the predicted value, the model predicted, or the value predicted by this model. So we're looking at, it might not be so evident on my screen, but we're actually looking at this point down here. I think that's the point that I asked about at 590 pages. Since that residual is negative, look at my scale on the left-hand side there. That residual is negative. That means that the predicted value is greater than the actual value. And that was a question that I asked about here.
And we sometimes refer to this as asking the students, is it an overestimate or an underestimate?
Yep. Very good. Very good. Okay, Tom, I think it's to you for a little bit of technology and see how we might attack this one on the TI-84.
Yeah, sounds good, Steve.
Okay.
All right.
There you go.
Okay.
Whoops.
Okay, there we go. I think we got the TI-84 up. So this was a little bit more extensive data set, but not too bad for managing. So I've taken the liberty, I went ahead and entered the data into our stat editor. So I'm just going to go and we'll check and see if I got that entered right. So I'm going to go to stat and edit. And in L1, list 1, I've got the number of pages for each of those books. And then in list 2, I've got their cost. Okay. And so what we're going to do, first of all, is just graph that data and calculate a regression. So why don't we just take a quick look at the graph first? I'm going to do that, I'll do a zoom stat.
And of course,
I forgot to turn on my stat plot. So let me go to stat
It
plot.
seems to be a pattern.
Pattern. So let's try turning that on. Also, let me go ahead and check that we actually have the right list. Okay, L1 and L2. That's exactly the list we've got. Okay, let's give this another shot. So I'll do a zoom stat. All right, okay.
Looks good.
So, something I did want to point out here is when Steve was showing the TI-Nspire screens, got the nice feature where the axes are not only labeled with values.
Yeah.
You can assign the names to the axes of what they represent. Here, we can see what these values are without the axes in picture, but if I turn on trace, it's going to jump from point to point in the table. Something I wanted to point out here is the first one that came up here is 500. Let's see, a 500-page book that cost $5.99. I'm going to hit the right arrow on my trace, and it jumps all the way over here to 700, 7.5. The reason for that is that's the second line in our table. So it's just going through the table in the order of the points. So it's not doing ascending order of the X's or anything like that. So I will jump from point to point. So I will, hit all my data values. But just keep that in mind that it's the trace order for a stat plot is in the order that the data is. So if your data is ordered, then it's going to go kind of from left to right. But if not, it'll just follow whatever arbitrary order they happen to be in. So we want to actually calculate a linear regression line for this. So let's take a look at, just kind of run through that again. So I'm going to do go back to my stat menu, and we want to go over to calc. And I see, oh, number 4, there's my linear regression.
Tom, pause just a second. Make note, mention that there's also a number 8 linear regression, because that bothers students and teachers. It's primarily there for those AP statistics people that like to write their linear regression equations as A plus BX instead of AX plus B. But it doesn't matter which one you use. One of it's not going to mess you up. If you could pick 4 today and 8 tomorrow and you'll be okay.
Yeah, it's and I'll do you have a particular preference, Vicki, of which one I should use?
No, because I usually use the down arrow and I go to the first one that I see.
Sounds good to me. All right. So we'll do a linear regression AX plus B. So I'll hit enter on that. And it's going to ask me, okay, what are the 2 lists of representing my paired data? Well, L1 and L2 looks good. Let me just now down arrow to, hey, good thing to do would be store this once we calculated it. So let me go ahead and bring up y equals, or not y equals, but my y variables. And let's do y1. And then finally, let's calculate it. And these values are looking an awful lot like the ones Steve got.
And I might as well go ahead and mention this. If this is not exactly, this particular problem is not exactly a model of an FRQ that would be on the AP pre-calculus exam, but there are some parts of this that could be in various places on the AP exam. If it were one of your open-ended where you've got to respond, you can write down rounded or truncated 3 decimal places to the right of the decimal. But you need to, that's why it's so important to store that equation in Y1 as you did, because you need to retain the stored values if you needed to make an approximation based on that regression line like we did in the previous problem.
Great. Yeah. All right. Why don't we take a look at the graph of this? See how we look. Wow, looks nice. All right. And I wanted to kind of wind up here actually looking at how do you do residuals on the TI?
Yeah.
And this is kind of nice because it kind of takes us through the computational steps, a way to think about residuals. So I'm going to go back to my stat editor. And we're actually going to calculate the residuals right here. So the first thing I'm going to do is over in L3, remember we have our regression equation stored in Y1. So I want to actually calculate the predicted values for each of those values in L1. Okay. So I'm going to define L3 to be Y1 of L1. So what that's going to do is it's going to take each value in the first list, plug it into my regression equation, and see what the corresponding predicted Y value would be. So let's enter that. Boom, there they are. Okay. Now the residuals That's the actual value, data value, minus the predicted value. Okay. So that's just how we'll calculate L4. So I'll go up to the header up there in L4. And L4, we're going to make that equal to list 2. That's the actual value.
Right.
Minus list 3, the predicted value. And there's our residuals. Fantastic. And we could just use this table to answer some of those questions that Steve had. Like I think he was looking at, was it 590, Steve?
590, yes.
Yeah, and we see the residuals negative, which means, okay, since that's the actual minus the predicted must have been bigger. Okay, so the predicted was an over prediction or overestimate. Okay. We want to actually graph these residuals. We could go to our stat plot. I'm going to turn off the one of the actual data points. And then I'll go back to stat plot and go down to plot 2, turn it on. And this is where I want to plot my residuals. Okay, so let's see, this is 2 different lists. We still want L1 for our first list, but L4 was where we had the residual values. So let me go down to L4 or Y list and put in list 4. And I think we're ready to roll. I'm just going to go to zoom stat. So fit.
Hey, pretty good.
Great. There we go. All right. And again, if we were to trace these, to find that 590, we'll just need to kind of run through the values until we get to that one in the list. There it is.
There it is.
Yeah.
And so, oh, go ahead, Vicki.
No, go back to the stat plot editor.
Sure.
I meant where we set up the L1, L4.
Oh, I'm sorry, the stat plot. Okay.
Yeah.
Stat plot setup. Got you.
Okay, so go down to number 2.
Okay.
And they could just put residual in the Y list.
Ah.
So go down to Y list.
Oops.
Yeah. Okay, and you have to press second stat, which is list. Once they've computed,
yeah, you have to get down to the Y list.
Yeah, and there it is right there.
Okay.
Resid. So if you, and now if you just press graph, we should get the exact same screen that you previously had.
There you go.
Yeah, that list resid is generated anytime you do a regression. That list resid is
and if
updated.
you haven't if you haven't done your regression,
it
like
won't be there.
Yeah, it'll say dimension mismatch
or
as far as
well, it either won't be there,
okay,
or it'll be a leftover list from the last time you did a regression.
The last time. Okay, gotcha.
And the odds of those dimensions matching is slim to none.
Slim and none. I usually get the dimension mismatch.
Yeah, and this answers the question. This is very slick, and it answered a question that came to my mind, was just putting residual here. I was thinking, well, how does it know we're doing L1 and L2? But you answered the question. That was the last regression we did.
Yes,
was the regression using L1 and L2.
Yeah, that's what it's based on.
Yes. So as long as you're doing it kind of immediately. And it makes sense. That's when you would be looking at the residual plot, is immediately after doing a regression. So,
but what you did reinforces that fact that the residual is the actual minus the predicted, which I think is an important connection that they need to make. Even if you just do this a few times and then let them go with the residual list, they gain understanding about what's happening with that residual plot by doing these different things.
For
Vicky,
sure.
Vicky and
Full about
Curtis,
doing that the long way, if you will.
Yeah.
So you could really see,
Oh,
okay,
for
how is the
sure.
residual being plotted?
Absolutely. Yeah.
I do that. And when I was teaching statistics, that's what I did too. We developed the residual the long way, quote, first, before I ever showed them that it did this. So
Yeah.
Because you really want to know what is that residual
Yeah.
representing. And so it's right there in front of us. Yeah. Very good. Great.
yes,
All right.
Steve.
I will, unless somebody wants me to play with
Steve's
something
got
else.
yeah, Steve's got a question.
I just have a quick question. Not that you
Sure.
have to do anything, Tom, Vicky, and Curtis. I just want to double check here. So there are many different kinds of regression that the TI-84 offers. For example, linear we just did, but it does quadratic and cubic and quartic and even exponential, I think.
Yeah.
So
Yeah.
for any of those,
Are fair
it
game.
automatically computes the residuals. Is that correct?
Yeah.
Yep.
Okay. Okay.
So that the students need to be familiar with linear, quadratic, cubic, quartic, exponential, logarithmic, and sinusoidal. And
Okay.
all of those are there.
Okay.
Right. Okay.
Pretty cool. Okay. Tom, I apologize. I've got just a little bit more here, and then I'm going to hand it over to you again, okay?
Oh,
Okay.
Uh-oh.
So those are the two problems that we had posted, and this last one that we'll have a little bit of time here to look at is free response question number 2 from the 2024 exam. And this one had to do with the sale of video games. So on t equals 0, there were 40,000 units of this game sold. Wow. And 91 days later, there were 76,000 units sold. And we're told in this problem that the number of units of the video game sold on any given day can be modeled by this function capital G, which is of this form, a plus b times the log of t plus 1. Let me just step back for a second. I'm just going to guess that this t plus 1 in the argument there gave some students some difficulty. I mean, we know why that's there because the log is undefined at 0, but I bet that gave some people some worry. It's not hard, but it looks kind of funny. So G of T is the number of units sold, and in thousands, in fact, and T is the number of days since the initial day of sales. Well, all right, this first part A here sounds familiar. Sounds similar to the very first question we started with this evening. Let's use the given data to write a couple of equations that we could use to find these constants A and B. And then, son of a gun, let's go ahead and find those two constants A and B. So here we go. Well, we have to do a little bit of interpretation. Vicky and Tom know that I'm big on this, translating the words into mathematics. That's a real valuable problem-solving skill. Being able to read a problem in context and be able to translate those words into mathematical expressions. And here in this context, we know that G of 0 is 40. On the initial day of sales, 0, we sold 40,000 units. And on day 91, we sold 76,000 units. Notice that I wrote 40 and 76 because it says here that G is the number of units sold in thousands. Now, we probably won't have an opportunity. We may have an opportunity to get to this, but in the scoring of this problem, there were allowances made, certainly for students who did this in thousands, who wrote 40,000, who wrote 76,000.
Yes.
And still did some good mathematics in there. So we followed along with the student. So here are my two equations. Let me draw a line here. Here are my two equations. Looking at the model given to me, at t equals 0, let me write that in here. At t equals 0, I have a plus b times the log of t equals 0 plus 1 is 40. A plus b times the log of t equal 91 plus 1 is 76. And you know what? For the purposes of the exam, I wouldn't have to do any other simplification. There are two equations that can be used to find those constants A and B. Now, how do I find them? Well, in the first equation, this isn't too bad because in the first equation, this just becomes the log of 1, which is 0, so that term drops out. So we know right away that A is equal to 40, sort of similar to the first problem we did this evening. And then I'm going to take that A equal 40 and plug it into the second equation right here. So 40 plus B times the log of 92. And let's see, what do you do there? Well, you subtract 40 from both sides, and then you've got to divide by the log of 92. And that gives me a B is equal to 7.961. Let me just note that when I solve this, I am reporting this value of B to 3 places to the right of the decimal, and I usually round, but it can be reported rounded or truncated. But as Vicky mentioned a moment ago, it is very important to store that value of B to the greatest degree of accuracy allowed by the technology. We might have to use that later on. So, Tom, let me just mention two other little things down at the bottom, and then I'll hand it over to you. This is how this problem was scored, basically. 1 point for writing the two equations, and 1 point for finding those two values, A and B. Pretty straightforward. Now, of course, there were lots of little things that we can look at here in the scoring notes. I don't know as we'll have the opportunity tonight. But there were lots of little things in the scoring notes to determine where a student would earn each of those points.
And those scoring notes are available in
Yes, they are.
on AP Central. And so
Right.
if you've not looked at them and you're curious about it, I'd highly recommend you go look for them in AP Central and download them and look through them. And
Tom?
instead, oh, just real quick, and all they have to do, they don't have to show any work for B because this is a calculator active question. So they could just report A equals 40, B equals 7.961.
Right. And so the assumption is that if they did that, Vicky, they did all the work on their
Calculator, yeah,
calculator active question.
yeah.
Okay, Tom, sorry, we're making you work this evening. We're
Oh,
going to let you do a little bit more on the TI-84, okay?
okay.
There you go.
Hey,
All
we
right.
just got a question for, uh-oh.
For uh-oh.
For uh-oh.
You guys went away. I clicked on something and you guys went away. We just got a question for a link to what Vicky was just talking about. Vicky, can you send me a link to that?
What, AP Central?
AP Central?
Yeah. Or I can look it up.
Yeah, I can look it up.
Yeah, if you'll just pop it in our chat and then I'll put it out.
I can't. Oh, I don't know where our chat is.
I'll
You might
look it
have
up.
to look it up.
I'll have to look it up. I'll look it
Okay,
up.
sorry about that.
That's okay. The AP pre-calculus course.
Yeah.
Or
Yes.
for the exam,
Yeah.
the actual exams.
Well, if you go to
Vicky,
AP Central, it's got like courses, and you just pick
Yeah, yeah.
math
I've got the
and
pre-calculus
okay,
one.
pre-calculus,
This is
and
good enough.
you should be able to. It's under a tab that's like exam.
I think this link is good enough. I'll put
Okay.
it in here.
Vicky, I think at this time too, probably the chief reader report is there.
Chief Reader Report is there, and there are also some student samples that you can use to guide yourself with what some of the students put and whether they earned credit or not for
How they
their
were
particular
scored.
responses. Mhm.
Yeah, how they were interpreted. Yeah.
And
Yes,
here's
yes.
a link to the reports. Let's
Okay.
see.
Yeah, and the
I'll
Chief
put it
Reader.
in the chat.
Okay.
Okay.
Chief Reader Report is excellent and very beneficial. So highly recommend
Indeed.
the teachers definitely look at this.
Sorry, Tom. Go ahead.
Hey, no problem. All right. Well, I was gonna kind of take the approach we did in number one, is just think about, oh, I'm told this as a logarithmic model. It looks like there's a log involved. What if I just did a logarithmic regression on the two data points that I have? So let's just take a look at what happens if we do that. I'm going to go to my stat editor here, and we still have all these values. I'm just this is a good way to show you how to clear out lists real easily. We'll just clear these all out. If you go up to the header and hit clear, back down, there it is. It's wiped out. So I'm just going to clear these real quickly.
There you are.
So that's funny. That doesn't really take effect until you arrow down, or you don't see the effect.
Yeah, you don't see the effect, but it's cleared there.
Okay.
And this will be two very short lists.
Okay.
Very.
Let's see, we had at time 0, and time 91. Was it
Yes,
91
sir.
days?
That's
Yeah.
correct.
Okay. Those were the 2 time values. And then our actual value we had at 40, I think.
Yep.
Mhm.
And then the other one is it 76?
76, yeah.
Okay, there we go. All right. So those 2 data values, and let's try a logarithmic regression, see what happens here. So I'm going to go back to my stat menu to calculate. And down there at number 9, you see that natural ln regression. And let's give it a shot. Okay, L1, L2, that looks good. And we'd like to see the equation, so let's go ahead and store that in Y1. And we're excited. We've got the drum rolling. And let's calculate this, see what we get. Uh-oh. Let's see. It says error domain. Oh, wow. Natural logarithm. Steve actually mentioned this. A natural logarithm of 0. It's not defined. And I had a t. So it was trying to do a log model using that raw value of t. You might be wondering about these examples. Notice that these are examples of expressions that are going to have undefined points. Okay, and so it's alerting us that that's the kind of thing is we have some value that's not in the domain that we of the function we're trying to work with. So you might say, okay, we just really need to do it
a different way.
But we'll show that we could make a little bit of it. Thinking of if we go back to the stat editor, let me hit stat editor. And remember that the argument of the natural logarithm was actually t plus 1.
Mm-hmm.
What if I change these 2 values to 1 and 92?
Right.
Now I've kind of done a little change in it. So these are x values where x is equal to t plus 1. So I've got to keep that in mind. And just wondered, will it work this time? Well, let's go back to the stat editor, calculate, do a logarithmic regression, same 2 lists. Let's store it in Y1. Let's try calculating with those values. Boom, there they are. And I think those are, now you got to remember that X that's here is actually representing t plus 1. Okay.
And yeah, and that's
Go ahead,
something
Vicky.
that students are going to have to remember that is the form of the logarithmic regression, that it's a plus b times the natural log of x. And that if they have a t plus 1 or something different, I can't imagine much else different than t plus 1, to be honest with you, but that they either have to do it a different way, algebraically, or even use that simultaneous solve would work, but we don't have time to show you that, but it would work. Or do what we kind of call a translation of the data. So where Tom changed the 0 and the 91 to 1 and 92.
And this happens actually a lot. I mean, I'm thinking especially I've seen models where it's really a translated exponential. And if you just do a straight exponential regression, you're going to run into issue. It won't be a domain issue, but you're going to get something that's not of the form that you're really looking for.
Right.
It's going to be a model that's for example, like Newton's law of cooling is not a straight exponential. It's a kind of a translated exponential. So
correct.
All right. I think I'll stop the share there.
So Steve,
sorry.
I don't know if we're going to have much time to do any more of that problem. Wondering if there are any questions, Curtis, that
I haven't seen any questions that have been related to the content. Just some quick questions about the links and some Nspire exam mode help.
okay.
Outside of that, nothing else
Well,
going on.
let me just mention a couple more things, Curtis, and we'll call it a
Okay.
night. Okay. These are part of at least the scoring notes that go along with this question. And I think right in this first part A here, there's some important things to remember. First of all, up at the very top here, Remember that any decimal approximation that a student presents as a final answer should be reported with 3 digits to the right of the decimal, rounded or truncated. And we are often asked this question about trailing zeros. Do you need the trailing zeros? No, you don't. If the answer is 2, you don't have to write 2.000. You can if you want, but you don't have to. And this often occurs, sometimes a student will make a decimal presentation error. That is, we need 3 digits to the right of the decimal, but for whatever reason, they only report 2. They report 2 correctly, but they don't give us that third one. Well, they will lose a point, or they will not earn a point because they have not presented the correct number of decimal places. But then in some sense, they will not lose any more points in that problem for that same sort of presentation error. And I think that's a good rule and a fair rule. So we wanted to make you aware of that. Just a couple of bulleted items down here in the scoring notes, and I think we sort of mentioned these a little bit here. So some students wrote their 2 equations like this. Even though they were told that G was given in thousands, they wrote 76,000 and 40,000. If they did that, they earned the first point. And I have a question mark over here because we don't know what they did for the second one yet. They were eligible to earn the second point. And the second bulleted item is something that Vicki, Tom, and I have all been talking about this evening. So look at this one here, if I've got this right here. Yeah, let's see. So suppose a student goes on to solve for A and B. They have the 2 equations and they go to solve for A and B, and they find their A is 40. That's pretty straightforward. And now they take a look at the second equation, and they recognize that B is equal to 36 divided by the log of 92. Well, what you might have a tendency to do is to plug in or ask the calculator to compute the log of 92 and just use 3 digits. And if you did that, in fact, you got the wrong answer to 3 digits for B. And that's why it's very important to use all of the technology, the greatest accuracy allowed by the technology. So this is not really a storing B, but this is a problem in finding that value of B and not using the greatest accuracy allowed by the technology. The third bulleted item is something that Vicki mentioned. We were not looking, or they were not looking here for work presented. So you could just simply present A and B, and the assumption was that you got those from your calculator. And again, students who used 40,000 and 76,000 would have to arrive at those 2 values for A and B, and that was okay. So great. Thanks, Curtis. I think we've run over a little bit here.
Just a couple minutes, but I think we're okay there. Thanks for the creative problems tonight, and thanks also for pointing all your questions to Vicki and Tom, making sure that I didn't have to answer too many questions tonight. No, it was great. Good stuff. Teachers, I put my email address in the chat box there. If you are looking for professional development hours, you can certainly reach out to me via email, and I will respond with a link to generate a certificate for that. Otherwise, we will be sending an email blast here in the next month or so with the new dates for the spring sessions. We have 4 more dates coming up in the spring that we'll be doing. I can't right off the top of my head remember the dates, but and Vicki's looking and scrambling to grab those, but that's all right. What we'll do is we'll send out an email blast, and also Steve will make a post in the Facebook community as he has in the past.
I think it's January 23rd. January 23rd.
January 23rd is the first one.
Yeah. Now let me mention, we are coordinating with the Tuesday night regular TI webinars.
Yes.
And so they'll kind of piggyback on each other, I guess you could say. Similar topics, different problems. So you could watch the Tuesday night one, and then 10 days later or so, I think would be ours on Thursday night. and
Yep,
they're
ends up
gonna
9 days later. Yep.
9 days later. Okay. Yeah, I can't count. I can do calculus, but I can't count. Anyway, they are going to be connected, similar topics and discussions, and I think that's going to be fantastic for teachers. And then, of course, ours for students is great too.
And if folks sign up or rather subscribe to the YouTube channel, they click that little subscribe button on this video, they will have the opportunity then also to get notifications for these. So that might be the easiest way to make sure that you know these things are coming. So September 23rd is the first one, and then we'll do them a month after that.
How about January?
All right. Do what?
Are you going to start the new
January 23rd.
January?
Oh, did I say September? I don't know where that came from. January 23rd. Good grief. I hope I typed January 23rd in the chat. I did. All right. Just making sure. All right. Thank you guys. We'll see you after the new year. Happy holidays, everyone.
Very
All right.
good.
Bye, everybody.
There we go.
Terrific.
Good grief. I was looking around there going,